right, we are going to start a new unit. It is called Solving Systems. Okay, there are 3 ways to solve systems. There is graphing, there is substitution, and there is elimination. Okay, this week we're going to focus on the graphing and the substitution way of solving. And then next week we will focus on elimination, and we'll do a nice little quiz test thing. Probably like a test. I'm not sure which one it is. I'll look it up. It's a quiz or a test next week. Okay? So, 3 ways to do it. Solving systems. It's nice to know what is a system. What do you think a system of equations is? A bunch of them, yeah. Technically, it's 2 or more. Linear functions. Okay, we're going to stick with just 2. Okay, but we could do more. Whoever has the music going, turn it off, take them out of your ears. We talked about this. We talked about it. Okay. So a solution to a system would be values that work for both equations, right? So if I'm graphing them, it's going to be a coordinate. So that means it's an X and a Y. Where the 2 lines intersect. Come on, pen. It's having a rough morning. There we go, where the 2 lines intersect. So I need an X and a Y that's going to work for both equations. When I graph those lines, that's where they intersect each other. Because they both have the same X and the same Y at that point. So it's a solution to both. Okay, so it's a coordinate point, an X, Y, where the 2 lines are going to intersect each other. Okay. There are 3 different types of solutions, and this is true for graphing, substitution, and elimination. There's 3 kinds of answers. Our most common answer is going to be the point where they intersect, okay? Where there is one solution, and it's the XY coordinate that they cross over. Okay? That is the most common that we are going to have. Now, when we have 2 lines, sometimes they are parallel lines. So if my solution is where they cross over, but I have 2 parallel lines, what do you think our solution is going to be? Where are they intersecting? They're not. So this is no solution. Do you remember what kind of lines were considered parallel? Remember, we did parallel and we did perpendicular. What made things parallel? They shared the same slope. Good. Good. So we're going to be graphing equations, solving equations. So if we notice that my mx plus b, if they both share the same mx, okay, we can recognize they're parallel and they're going to have no solution. They're never going to cross. Okay, but what if they have the exact same slope and the exact same y-intercept? It means they're the exact same line, right? So if I have 2 of the exact same line, what x's and y's are going to be true for both? All of them. Yes, all of them. So this is going to be infinitely many. Okay, this is going to have the same slope. It's the exact same line. Okay, the same slope and the same y-intercept. Okay, so we end up with the exact same line. All right. So we have 3 strategies: graphing, substitution, elimination. All 3 strategies have 3 possible answers. The one point where they cross over each other, There's no solution if we get parallel lines with the same slope, or there's all the solutions, right, infinitely many, if we end up getting the exact same line, meaning same slope and same y-intercept. Okay? Today is very visual. We are going to graph our lines and see what we get. So when we graph lines, what's our favorite way, our favorite form of graphing them? We did standard, we did slope, point slope form, and we did slope intercept form. Which one's our favorite? Slope intercept form, yep. And what is that equation? Mx plus b, yep. Remember where m is the slope, so how we move, and b is where our line begins at the y-intercept. Our first two examples already have it set in that form. Isn't that nice? Okay, so let's focus on number one. We have y equals x minus 8. So what's the y-intercept of x minus 8?
Oh, I was looking at the bottom.
The negative 8, right? So 1, 2, 3, 4, 5, 6, 7, 8. That's where we're going to start. This is negative 8. Right? And how is this going to move? And now back to you. What's my slope? Yeah, my slope is 1. Okay, I have a 1x right here. My 1 is technically our slope. So we're going up 1 and over 1. Okay. Rulers are important. We need to be exact. As close to exact as we can be. There we go. That's better. All right, now let's graph our second line. I'll give you all a second to connect. Our second line has a y-intercept of what? Has a y-intercept of 1 and has a slope of negative 2. Good. I'm going to go ahead and put it over 1. Just so I can see my rise and my run, right? So y-intercept is positive 1. Here we go. If it's negative 2 over 1, which way are we going to go? There you go. Down and over. So down, 1, 2, over, 1, 2, over, 1, 2, over. We don't have the same slope. So they're not parallel and they can't be the same line if we have different slopes. There's one point where they're crossing over each other. It's this guy right here. What is that point? What is the x value? And what is the y value that they intersect? Looks like it's an x value of what? What's our x value? Nope, we're looking at this purple. X's go across. 1, 2, 3. My x value is a 3. And our y value, it's about right here. 1, 2, 3, 4. There we go. So we have one solution where they cross over each other, and it's at the point 3, negative 5. This is our solution. So this is what we're going to do over and over and over again. We've already graphed lines this year. Okay? We know slope. We know y-intercept. Ready for number 2? Are they already in slope-intercept form? The y equals mx plus b. Yes, they are. Okay? So I don't have to rearrange anything, which we're probably going to have to do on the back. But right now, there's no rearranging. We already have it in slope and intercept form. So my first one, y equals 1/2 x plus 9. I also already tell, by the way, my slopes are not the same, right? But our numbers in front of our x's, they're not the same, so it can't be parallel and it can't be the same line. So we're going to predict they're crossing over somewhere. My first equation, what is the y-intercept? Our y-intercept, nope, I can't spell. Intercept, come on. There we go. It's going to be 9, and what's our slope going to be? 1/2. So I'm going to go to my y's, count up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And my slope wants me to go which direction? Good, up and over. I can go up 1/2, but I can't really do it again. So how can I go backwards? You're already proving to me, by the way, that you can't handle sitting next to each other. It's the first day you're sitting together. We talked about this. Thank you. If I can't go up 1/2, I can do what instead? I can go down and backwards. Down, backwards, down, backwards. Now we got y equals negative x plus 6. Where are we going to begin the line? Where is our y-intercept going to be? Is it the negative or is it the 6? It's going to be the 6. Remember, it's mx plus b. B is where you begin. That's your loose number. That is your y-intercept. So we're starting with a 6. 1, 2, 3, 4, 5, 6. There it is. And our slope, yep, it's the negative, which is negative 1. I'm going to go ahead and put it over 1 as well. So does that mean we're going up or we're going down? We're going down and then over. So down 1 over 1. And to go backwards, I can go up and then backwards, right? They don't have to be whole numbers, but for the sake of learning this, we are going to keep them whole numbers. Okay. So it's beneficial to create all the points that you can fit on the graph if you can, because then you'll probably actually mark the point where they cross over each other. I'm going to do green this time, make it easier to see. So they are crossing each other right there. So we do have one solution. What is the x value? Hold on. X is this guy, right? So that one is negative 2. And then what's my y? My y is 8. Good. So we have one solution at negative 2 and 8. Questions for me? Okay. How does 3 look a tad bit different? Yeah, they are in standard form where our x and our y are on the same side. So I have negative 3x plus y equals 8. Well, I want y to be by itself, so I got to move my x out of the way. How am I going to move negative 3x to get out of my way? We're going to add it. So here we got a little bit of work to do before we start graphing. So when I add 3x over to keep it in my, I'm going to kind of do a little arrow. Boop. So we have this guy. We're going to add 3x. So y is by itself. Does that give me 11x? Can I do 8 plus 3x? No, 8 does not have an x, does it? They stay separated. Variables always go up front. So 3x, and then we still have that positive 8. And that's what we're going to graph. What is the y-intercept for that one? This one is 8. Good. So this is my y-intercept. 1, 2, 3, 4, 5, 6, 7, 8. All right, and how are we going to move? Why down? It's not negative. No, it's not negative anymore, right? My slope is 3x. So what Jaden is saying, my slope is 3 though, right? So I should go up 3 and over 1. Jaden noticed we can't do that. We go off grid. So what could I do instead? We can go down and backwards. 1, 2, 3, backwards 1. 1, 2, 3, backwards 1. Like that. Okay. If you have colored pencils, might be beneficial. If you're a very visual person like myself. If you're not, that's fine. If you don't have them, you can label them A and B. You can draw arrows. Just do whatever you need to do to keep yourself organized. Our second equation, negative x plus y equals negative 2. It's in standard form again. So that means I want y by itself. I got to move negative x over. How are we going to move negative x? We're going to add it. Good. I get y equals. Do I put negative 2 and x together? No. And what always goes up front? Yeah, our x goes up front, and then we have negative 2. So what's our y-intercept for this one? There you go. So start at the origin, go down, 1, 2. Here we go. What is our slope going to be? 1 over 1. There we go. So we're going to go up 1 and over 1. And instead of up and over forwards, to go backwards, we're going to go down. Down and back, back. Do these lines intersect? Yes, they do. So we have one intersection. I'm going to draw backs around this. We have one solution. Where is it at? So these are my x's, right? The sideways. So if I go straight up, what x value was that? There you go. Remember, this is the origin, right? So 0, 1, 2, 3, 4. Yep, that's -5. 1, 2, 3, 4, 5, 6. I heard someone whisper it. -7. So our one solution is going to be the point -5, -7. Yeah? Are we okay to rearrange from standard to y-intercept? Number 4, one of them is nice to go, right? The y equals -1/2 x plus 2. That one's fine. But look at the first guy, standard form. X plus 2y equals 4. So we gotta rewrite this one. Oh, but we're gonna do blue first. There we go. So this guy right here, x plus 2y equals 4. I want to get y by itself, and I get the x over. How do I get x to the other side? Minus. We're going to subtract the x over. We have 2y equals -x and +4. Well, it looks like this time I got more. Last time it's all I had to do. But what's different for this problem? There's a 2. How do I get rid of that 2? Divide it. There you go. So now we have y equals -x over 2 is -1/2 x. And then 4 divided by 2 is 2. So let's graph this guy. What is our y-intercept? It is at 2. So origin and then up 2 units. There we go. Y is 2. What's our slope going to be? Good. Down 1 over 2. Down, over. I can go up and backwards if I wanted to. Get some more points on here. Okay. So this was one line. What's our other line? Oh, what? It's the same thing. Y'all see that? The one we haven't graphed yet. Y equals -1/2 plus 2. It's the exact same line, isn't it? So what does that mean about our solutions? Infinitely many, yes. This is our other one, which was the exact same. 2, down 1, and over 2. It was the exact same line. So if they're the same line, every x and every y that works for one equation is going to work for the other. It's the same thing. So here we have infinitely many solutions. Whoa. Are we still feeling okay? Each one, there's something a little bit different about it. So if you ever have questions, please ask. Each example is something new. So 3 and 4 focused on rewriting from standard to y-intercept. 3 focused on just moving your x value. 4 showed us we had to move x and then also divide by a number if it was multiplied by y. And number 4 showed us an example of an infinitely many where you've got the same line twice. Number 5. What is number 5 showing us, you think? That top one, standard form, right? That's not new. We just did that. Look at that next one. Y equals -7. That's new, right? Okay, let's do with the first one, the first equation. Because we just practiced this. Ooh, blue. So x plus 3y equals -15. Tell me what to do to get y by itself. Subtract the 1x, yep. And then -15, good. You're probably doing it right, but make sure you say divide by 3. Don't divide by 3y, just divide by 3. Yeah. So what's -x divided by 3? What's technically there? There you go. -1/3x. And -15 divided by 3? -5. All right, what's our y-intercept? -5. So starting at my origin, we're going to go down. 1, 2, 3, 4, 5. Right? These are positive y's. These are negative y's. And then my slope, it's -1/3. So we're going to go down and over. 1, 2, 3. Down. 1, 2, 3. Oop, 3. I can also go up and backwards. 1, 2, 3. 1, 2, 3. 1, 2, 3. There we go. All right, so there was line 1. Okay, now time for line 2. Well, y is by itself. We have y equals just a -7. What kind of line only has a y? I'm going to bring back Hoybucks. Hoybucks, hold on. Hoy, come on, there we go. Hoy, there we go. And Bucks. See how the y is by itself? Under the h, it's a horizontal line. So I'm going to draw a horizontal line where? At -7. You know this is -5, -6, -7. This is going to be horizontal. We're going to go straight across. The only thing we have here are y's that are equal to -7. Your y's can never change. Do these two lines intersect each other? Yeah, they do. We know the y has to be -7, right? But what is our x going to be? Let's see. Here's my origin. 1, 2, 3, 4, 5, 6. I know, it's hard to see sometimes. That's going to be an x value of 6. So my x is 6, and my y has to be -7. Questions for me? Excuse me. Ready for number 6? Yes, no, maybe? Yeah? All right. Well, we like y equals x plus 5, right? Can I pause and you just graph that first one? Do you have to rearrange it? No, you can go ahead and do y-intercept and slope for this guy. So you just graph that one line, y equals x plus 5. All right, so if you've graphed y equals x plus 5, you had a y-intercept of 5. Your slope is technically 1 over 1. So you went up and over. You could also go down and backwards. Okay. The next equation, x minus y equals 2. You subtract x over. So now I have negative y equals negative x plus 2. Can I graph this the way it is? No, this is the new thing for number 6. What do I have to do now? And how do I get rid of a negative? Technically, it's being multiplied by negative 1. So to get rid of a negative, we divide by negative 1. Come on, pen. So if you divide by negative 1, all of the signs are going to change. So we have positive y. Now I have positive x, and now I have negative 2. So where is this line going to start? Yeah, so here's my origin, drop down, 1, 2. And what's our slope going to be? Not negative. It's positive now, right? Up 1 over 1. Notice anything? Oh, they're parallel. How do you know that? By the equations, how do you know that? They have the same slope. Good. They both have a slope of 1x. Beautiful. And how do you know that? By looking at the actual graph. They are never going to touch. They look parallel. That's nice. Okay, so we've established our parallel lines. So what does that mean about the solution? What's the x and the y that's going to satisfy both equations? It's not. Good. So what's my answer? No solution. Ooh, someone said 0, and I'm happy you said that. You said 0 solutions, which means no solutions. But if you just say 0, you got to watch out because there is a 0 on the graph, right? So like if you just put down the number 0, I might think you're talking about the origin. So make sure you specifically say no solutions. I would just keep 0 out of it so there's no confusion at all. What is happening with my pen? Come on. Oh my goodness. No solution. Goodness. All right, we got 2 more. You ready? 2 more. Nope. This is all we're doing. As long as we get through notes, you do not have homework. I know, right? We're going to practice this tomorrow. So what I would have given you for homework tonight, you're actually going to do in class tomorrow instead. Well, we're spreading them out this week. Same thing with Wednesday and Thursday. We'll do notes Wednesday, and what would have been homework, you're actually going to do in class on Thursday. Okay?
We're going to rearrange your top.
Yep, we do have to rearrange. We have to rearrange both of them, don't we? Yeah, they're both. What form is this? Right now, they're both in standard form. Good. So let's rearrange them. Let's work on 3x minus 5y first. 3x minus 5y equals negative 35. Okay. That's our first equation. Tell me what to do. Minus the 3x. Okay. Can I subtract negative 3 from negative 35? No. They are not the same. We have negative 5y. Yeah, hold on. Make sure my variable's up front. So I have negative 3x and then negative 35. And we are going to divide by negative 5 each piece. Xavier, what's that going to make my slope now? It was negative 3 over negative 5. So what is it now? Okay. And then what do I get when I have negative 35 over negative 5? Positive 7. Thank you. So 3 over 5x, and that becomes a positive 7. So this is the first one we're going to graph. Where do we start it? At a positive y, right, of 7. So 1, 2, come on, 1, 2, 3, 4, 5, 6, 7. And then how do we go from here?
Up 3 over 4?
Yes, up 3 over 5. 1, 2, 3, 4, 5. I can't go up again.
Down.
Yep. 3, 1, 1, 2, 3, 4, 5. Down 1, 2, 3. 1, 2, 3, 4, 5. Good. All right, you try to rearrange the next one. The 2x plus y equals negative 6. I want you to rearrange it. So that way y is by itself. 2x plus y equals negative 6. You rearrange that and graph. So for this one, you should subtract 2x to the other side. So you have y equals negative 2x minus 6. They don't go together, so negative 2x is up front. That means our slope is negative 2 over 1. So we're going to go down and over. And we're starting the line at a y value of negative 6. So I went down 2 over 1. And to go backwards, I can go up and backwards. Plotting all my points, I can see a definite spot where my two lines do cross over each other. So they have one solution. This x value right here, remember these are negative x's, is what? 1, 2, 3, 4, looks like negative 5. And this y value, 1, 2, oh, what am I doing? 1, 2, 3, looks like a y value of 4. So what's our solution? How do we write our coordinate points? There you go, negative 5 and then 4. It's always x and then y. Boop. Did I go to the next equation? Yes, I did. I should put it down here. There. All right, last one, friends. What's up? Oh, yes, it is going to be horizontal. Good. So, no, it's not horizontal. Vertical. Hoi vux. Vux has the x. That's vertical. Okay. So you're going to go over to where x is negative 2. Right here. This is a vertical line. Positive x, negative x, right? So find where x is negative 2. That's right here. And vux means it's vertical. Meaning every single x value on this line is negative 2. So all x's are negative 2. So on our notes, we have an example of a horizontal and a vertical. So don't lose these, right? You're going to need this tomorrow. We have an example of all solutions. We have an example of no solutions. Okay? And then we have lots of examples of the one solution, which is our most common. Tell me how to get y by itself. What's the first step? Subtract 3x. Can I do negative 18 minus 3? No, it stays separated. So I have negative 2y. Come on. We're almost there. What is it equal to? Negative 3x and negative 18. Because we moved that 3x over by subtracting it. Divide each piece by negative 2. So we're going to have y is equal. Negative 3 over negative 2, number-wise doesn't change, but negative over negative, it's now going to be a positive 3 over 2. Negative 18 divided by negative 2 is positive 9. So this is our second line. 1, 2, 3, 4, 5, 6, 7, 8, 9. And up 3 over 2, I can't even do that. So what am I going to do instead? Down and back. 1, 2, 3, back 2. Oh, look at that. 1, 2, 3, back 2. The very first thing we drew was where they're going to intersect. What is that solution? All right, so we definitely know that negative 2 has to be the x. It's my only choice. And then my y is 1, 2, 3, 4, 5, 6. Yep. So our solution is negative 2, 6.